Welcome to my video today. I'm going to be looking at Cura 5.4.0 for the Easy 3D K9 Mini 3D printer. What I'm going to do today is a complete walkthrough of what you need to do to set Cura up for the K9 3D printer. First of all, I'll show you how to load the configuration file from the SD card. What you need to do is to go into your file manager and go to the SD card and go through the folders until you come to the file. And for Windows, and this is the file, the configuration file for Cura. What you need to do is simply drag it and drop it into the window. Okay, and all you need to do is to open as project and then follow the instructions, and then your version of Cura will be set for the K9 3D printer. I don't want to do that for my own setup of 5.4.0 because I've already done it and I've tweaked it a little bit away from the default settings. After you've imported the profile from the file, what you need to do is I'll close out of this now. Just go and verify manually that the settings are all correct. You just go to Settings, Printer, Manage Printers, Machine Settings, and there you will see the bed and the print volume 100 by 100 by 100 millimeters, and you'll see heated bed is unchecked because there isn't a heated bed. The extruder is 0.4 millimeters and filament is 1.75 millimeters. I'll close out of that. If you look in the printer here, you've got the K1, K2, K7, X1 and X2. It doesn't mention K9, but that's not an issue because those printers, as far as I'm aware, use the same build volume and the same hardware as the K9. So it's, to all intents and purposes, the same thing. And so you don't need to worry about the fact it doesn't say K9 there. Having checked the machine settings, I'm now going to go and load the model. This will always be your first step. When you go to print anything, you need to load the model into the slicer. In the top left-hand corner, you need to go to File, and then Open Files. And my computer is already set to go to this directory here for the 3D Benchy. But you can obviously choose a different directory depending on where the STL file that you want to open is. But I'm going to choose here the 3D Benchy, and then Open. And it will be imported into the slicer, and there it is, it's in the window. Now I can show you how to navigate round the window. In order to change the viewing angle, you just need to right click on the mouse and just move the mouse around. You can pull it backwards, sideways, up and down to see the model move round, and you can focus in on various parts of the model. Let's look at the text on the bottom here. What you need to do is zoom in is just use the mouse wheel, and that will zoom you in and out of the model. And you can of course angle it to reach the specific part you want, and then zoom in and out with the wheel. You can see here the blue, red and green lines here. That indicates the front left corner of the bed, which is normally the origin for everything, the front left corner. And it means that you can orientate the model in 3 dimensions if you know where that front left corner is. And that's normally the case with most slicers, not just Cura. All of the slicers will be done like that. I'd just like to show you how to use the adjustment panel on the left. In order to enable it, you need to left click on the model, and then it gives you access to these adjustments here. The adjustments allow you to move the model around the print bed. You can move it by clicking on the handles here. You can move it to the left and to the right. You can move it forwards and backwards, or you can move it away from the bed by lifting it up using the blue handle. You notice if you move it up and then let go, it will drop down onto the print bed again, where it says you've got here, the checkbox is checked to show drop down model. Another feature of this is that if you notice the coordinates here have changed, and that means that the model is no longer in the middle of the print bed. Here you can see it looks like it's forward and to the left. If you want to reset it again, you can right click the model and then go to reset all model transformations, and now you can see the coordinates have all gone back to 0. The second adjustment is scale, where you can increase the size of the model or reduce it in real terms here by adjusting these percentages or adjusting these handles again. There's an option to click uniform scaling, and normally that would be checked. And that means that when you adjust one dimension, the others will automatically increase as well. And you can see that if we do that, Cura automatically puts the model back on the build surface each time. So I made it go below the build surface and it's put it back. And you can see here that the percentages have all increased in numerical terms here, and you can of course adjust these separately by writing into the boxes. And because uniform scaling is checked, the model will overall increase accordingly. Conversely, you can take this out and adjust these parameters individually, so that the whole model doesn't change. Only the, in this case, the Z-axis is changed, but none of the other ones have. So you can make it lower, fatter or thinner in different dimensions here without changing the others. And this might be useful if you are designing a particular printed part turns out to be slightly too small or slightly too large. Using this function, you can actually correct that on the fly. So that can save quite a bit of time if you're trying to do something quickly. I'm just going to put back the uniform scaling, and then I'm going to click to reset all model transformations, which will reset the model again. But you also have this reset here as well. The third adjustment is rotation, and again you have handles, so you can adjust rotation in all these different directions just by clicking on the handle. Again, there's a reset button. You can lay the model flat, and also you can select a face to align to the build plate. Like if you wanted to print it on the roof for any reason, you could quickly do that. It's a quick adjustment that you can make to actually reorient the model according to how you want to print it. The fourth adjustment is mirror, and you can again use these handles to change the orientation of the model quickly. I'm just going to reset that again. These last two, I haven't really used these and I'm not sure what they actually do, so I'm going to set those aside. for the normal person wanting to just simply print a model, what I've given you is enough to actually do that, and these other things you can experiment with over time. I dare say that there's lots of useful things here. It says support blocker on that one, which sometimes what you can do is, if you want to only have supports in specific places on the model, instead of allowing the slicer to choose where the supports will be, you can actually just choose it yourself. And I imagine this is something to do with that. But as I say, I haven't used these and I'm not going to go into them now. So now we've chosen where we want to print the model, I'm just going to reset this again. It is reset, so that's fine. When you want to slice the model, you'll notice that there's a bar on the top right of the window which shows all of the settings in a summary, which means that you can check the layer height, the infill, support material, and bed adhesion. But normally what you want to do is to check the settings individually, and I would normally recommend that everyone do that, just to see what has been selected for us. Now the layer height, which is the overall layer height, is shown as 0.15, which means you know that most of the model you're printing now will come printed at 0.15, which is a good quality setting. When you choose the layer height, you have various settings to choose, as you can see from this list of profiles. Normally the coarser it is, the quicker it will print, but the lower will be the quality. And of course, the thinner the layers, the better the quality, but the longer time it will take. And it's a decision that you need to make about whether you want quality or speed. And we'll just run through the settings here. Initial layer height is set at 0.3, and it's normal to choose a thicker layer height for the first layer. Initial layer line width is 100%. Initial layer line width is one thing that can help you with bed adhesion if you do have a problem with bed adhesion. That's more likely to be the case on people with printers with glass beds, but actually the K9 has a kind of a plastic surface for the bed, which is actually extremely good with layer adhesion. So there's really no need for any initial layer line width to be larger than 100%. If you changed it to say 140%, you'd have a better chance of adhesion with a glass bed. The wall thickness I'm going to leave alone. I'm going to leave that at 0.8. The same with bottom and top thickness. Infill is 10% and infill pattern grid. Printing temperature is 200. I'm going to adjust this because I know that the K9 printer will print PLA at 180, and there's no need to waste any energy printing at 200 when we can print at 180. But if you want to print at 200, there's nothing to stop you doing that. With regard to silk PLA, I've tried printing that with the K9, and I know that 180 isn't sufficient. Although it will produce a print at 180, in order to get the kind of a metallic shininess, you really need to go to 200 for that. So definitely, if you are printing silk PLA, you need to stay with 200. Now we come to speed, and the print speed for the K9 should be about 40. If you go to the EasyWare slicer, you will see that the print speed defaults to 40, and that's what I'm going to set this at, just to be on the safe side. And also the travel speed needs to be 50. Again, that's setting I'm taking from the EasyWare slicer. And I'm going to leave any other settings alone. I'm going to leave wall speed alone and initial layer speed. So I'm setting the print speed at 40 millimeters per second and the travel speed at 50 millimeters per second. And these are settings that I've obtained from the EasyWare slicer. And travel, I'm going to leave it alone. Cooling, I'm going to leave it alone. Fan at 100%. Support. Now, generate support. Do we want support? Well, with the Benchy, normally support isn't needed, and in fact it shouldn't be supported because it wouldn't print correctly if it was supported. So definitely with the Benchy you don't need support. And build plate adhesion type brim, because as I've discussed before, the adhesion with the K9 is good, you don't need that. Normally with the K9 it will be suggested that you used a raft, but that's a matter of personal choice. Because the print adhesion is so good, I don't think raft is really needed, and I'm going to say skirt. Certainly if you've changed the print bed material, as I've done, to the Ender 3 magnetic bed, you can see how I did that in the my other video on the K9, the tips and tricks episode 1 video, where I show you how I changed the print surface to the Ender 3 magnetic bed, and I did this to increase the quality of the bottom of the print. Because the original K9 bed is actually a perforated sheet, what happens is that the bottom of the print will sink into the bed and any features on the bottom of the print will be lost. So I've changed it to the Ender 3 magnetic surface because it's then possible to obtain some definition in the bottom of the print. And as you can see with the Benchy, we actually have text that needs to be produced on the bottom of the print. If you have a print bed where the model sinks into it, you will not have any definition of anything on the bottom of the print. I've already looked at that in my other videos, how you can see that with the raft, the text on the bottom of the Benchy is not printed at all. So that's the reason why I decided to use the Ender 3 bed, and I have had some luck with actually getting this text shown, so it was definitely worth doing. And also it's easier to get the print off, but the adhesion remains the same. So as we don't need adhesion, I'm just going with a skirt here, and the reason for going with a skirt is to ensure that the nozzle is running correctly at the time it prints the first layer, because it primes the nozzle and the material is coming out evenly before you start printing the first layer. And again, that is to ensure that that text will be shown correctly, or at least as much as possible. So now we've been through all these settings and we're happy with them. What I would suggest, if you are using the K9, that you look particularly at print speed and travel speed, because these were set a fair way above the settings from the EasyWare slicer, which was actually designed for the K9. So I would suggest that you change these settings away from the default for Cura and back to the settings which you can find in the EasyWare slicer, so that you can be sure that you're not setting anything more than the printer can do, and you're not pushing it to do performance that it's not designed for. That's just a safety thing, and also to hopefully extend the life of the printer, because you're not asking it to go faster than it should go at. Now we're happy with all these settings, we can then press the slice button, and the slicer will now produce the tool paths for the printer. You can see that the expected print time is 1 hour 43 minutes, and normally the Benchy should print in roughly an hour, but because we've chosen these speeds, 40 millimeters per second and 50 for the travel. That's the reason it's a longer time. If you want to see the sliced model as it is, it's always a good idea to check. You can look at the preview screen, and that will show you what the model will look like, what the toolpaths for the printer are, and what the model will look like. So I'll just check that. And here we are. So this is the actual layers we can see here that the slicer will code into the G-code file, and that the printer will be following to actually produce the model. So if I just contract this window here, we can look down through the model. We can manipulate the model, of course, so that we can see from the top and from the sides. And if you go to the bar on the right side of the screen here, you can left click that and move it down to look through the actual layers. And you can see how the infill material is and how it will support the horizontal surfaces of the print. Another useful feature is if you turn the model over to the underside, you can actually go up from the bottom as well. So if I just do that, you can see it from the other side as well. Now you can see the text here, as I've talked about this before, is only one layer thick. If you go to layer 2, you can see that the text immediately disappears, so we can see it's only one layer thick. And also you can see how it's printing the brim here. As I say, it's just a good way of priming the nozzle to make sure that the material is coming out evenly before you start printing the first layer of the model. So if I rotate it round here, I'll show you the text on the stern of the Benchy. If I can zoom into it, you can see here that there's text here which is actually quite difficult to print, and this is what I've been struggling to print. You can see all of these little white dots here are actually the layer starts. When the printer starts and ends a layer, it will start and end a layer at a particular point on the model, and all of the little white dots show you where it's starting and ending a layer. You can see that some are on the edge of the hose hole here, some on the edge of the door. We can control where they appear. As you can see, you've got some on the chimney and some on the side of the boat, the hull here. They're spaced randomly around the model. And we can actually control how they appear if we go into the settings again. What I might do is have to hunt for that. So another thing is you can do is search for a particular setting if you're interested. I'm just going to go to Z seam. Oh, seam, and then oh look, it's already come up with that. It's giving it in the settings here. And it says sharpest corner, so that means you can alter where that actually appears. You can go for shortest, random, sharpest corner. And because we changed these parameters, it means we have to slice the model again. But I'll just show you how you can change that. And you can see now we've chosen random, that they're everywhere now. That might help with the quality of the print. And when I look at the benches, which I will do in a different video, I'm going to go through all the benches I've printed with the K9. You can see how that affects the print quality. If you keep them all in one place, sometimes it can cause a bit of unevenness, whereas if you spread them around, the unevenness is spread around as well, so it can improve the quality. I'm going to put this now back to sharpest corner and then slice the model again. So now we've been through all the settings here, we're actually ready to print the model, and what we need to do is just to save it to the SD card. And in order to do that, you just have to say save to removable drive. You notice that the slicer automatically chooses removable drive, so it saves you having to do that. But you can save to disk if you want to, just by clicking that little arrow. So what I'm going to do is just save to removable drive, and it gives you a message to say that it's done that. And it also gives you the ability to eject the file. But what I normally do is to actually open the SD card just to check how it is. So I'll just go to File Manager and then scroll down to the SD card. And as you can see, there's a single file in the root directory, which is the G-code file we've just saved. The fact that there's an SDL file also in the root directory doesn't make any difference, because the printer will only look at the G-code files. But normally with 3D printers, they have a little screen where you can choose the file that you want to print, but because the K9 doesn't have that screen, you have to make sure that there's only one file in the root directory, that is the one that you want to print. I have created a little folder here where I keep the G-code files that have already been printed, so that they're no longer in the root directory. Which means that when the printer goes to look on the root directory to find the file to print, there's only one there, so there can be no confusion about what needs to be printed. And this isn't actually a bad idea in general with 3D printing, because very often, if you've been using one SD card for a very long time, it'll have many files on it. And when you go to select the file, it's quite easy to actually select the wrong file when you go to print. And I've done this many times where I've actually thought I've selected the correct file, gone away and come back and found the printer's produced something completely different that I didn't expect. So as a rule of thumb, I would say it's a good idea, it's good practice to clean out the G-code files and put them in a separate folder before you go to take the SD card to the printer. That will save you making mistakes, costly mistakes. So now what we'll do is to eject the card. You might not have the eject button still available here, but what you can do is go down into the taskbar here and eject that. Now what you need to do is to take the card and put it in the printer. With the K9, the SD card needs to be with the gold contacts facing up, and then you insert it into the printer, and then just check, have a double check to make sure that there's filament on the printer, and there's that the printer's been correctly trammed or leveled before you start using it. I have found with the K9 that it does require frequent tramming. There are some printers that don't require as much tramming, but other printers you will have to you may even have to re-level and tram the bed on each print. And I think with the K9 printer actually falls into that latter category, so I think it's a wise idea to tram the printer on each print. So once you're happy that the printer's all set up and the tramming's been done effectively, you've inserted the card, all you need to do is press the little button on the front of the printer once, and then the printer will start to prepare the print. Another thing I suggest with 3D printing is to always watch the first layer go down, because very often problems will happen at the first layer. If there's no layer adhesion, it will happen at the first layer. And then you've got the opportunity to correct the situation. You can stop the printer, again with a single press on the button will stop it printing, and you can correct whatever problems have occurred. So watch the first layer go down, and then if it goes down effectively, you can go away and leave the printer for the requisite time, and then come back, and it's not completely guaranteed, but almost guaranteed you'll come back to see a finally completed print. Another thing I like about the K9 is actually the printer itself, because it uses very little electricity. So when it does go into standby after it's printed, you know that you're not wasting any large amounts of electricity leaving it in standby. For instance, if you were to start the printer in the morning and then go to work, you know, you'd be confident that it wouldn't be using a large amount of electricity while it's on standby. So that's it, and thanks for watching. If you did find the video useful, please consider liking and subscribing. See you in the next one.